Hello friends, today welcome to a new session of Apteasy, Aptitude Made Easy with Amit. We will take an example of conditional probability. So we'll see today an interesting topic, an exciting topic of probability. Not exciting? Well, probability is very important in uh, wherever you join. If you want to join in any institute or organization or even for pursuing higher studies. So in there are examples where you need probability. So a basic knowledge of it is very important, and it's also important from the point of gate exam or net exam. So today we will see a probability example, and we'll give a overview of probability topic as well. So today we have taken a question: the probability of any random person getting infected by COVID-19 is 1/1000. In reality, it is much lesser, and this is just an example. Nothing, not any real life. It's just an example given. So just take it as an example only. An Indian startup from Pune has developed an indigenous COVID care test kit in a record time of 7 days. The kit gives 99% accurate result when the test is administered to healthy people. The kit gives 5% false result as well when the test is administered to infected people. A randomly tested person has turned out to be positive. What is the probability that the person is actually having COVID-19 infection? This may seem a bit complicated, but I will tell you how you can solve it very easily. And as I always say, aptitude is something that you have to regularly practice, right? Just like you do physical exercise. So if you do one day physical exercise, you cannot reap the benefit. You have to continuously do for days. Similarly, you have to do numerical exercises. So just like you do physical exercises, you have to do numerical exercises every day. Then only you really get the benefit of it. You can do it using your own any aptitude book that you have. You can also study or go through our aptitude book, Apteasy. This is also available now in Kindle edition. So you can easily search Apteasy on Amazon and check the book. If you like, then you can subscribe for a nominal price. So let's go back to our problem. The problem was any infected person of COVID, the probability is 1/1000. This is one part. And then there's a kit which gives 99% accurate result when it is administered to healthy person, and 5% false result comes when it is given to infected person. So before I understand this is a bit complicated, it may seem. So let's go to the basics of probability first, and then we'll tackle this problem. So basic of probability. Let me tell you before we proceed that understanding probability requires a prerequisite. You should have prerequisite knowledge of permutation and combination. Very important, because most of the problems in probability are basically related to some arrangement or selection process. So if you want to understand how this arrangement and selection process works, then you should know how to do it through permutation and combination. So this is one thing that you should keep in mind. So once you are done with permutation combination, then only you jump to the probability chapter. Now in probability we call this as experiment, which is basically phenomenon where outcomes are uncertain. So you suppose you roll a dice, or suppose you take out a card from a pack of 52 cards, right? So these are, uncertain, you don't know. Or if you toss a coin, so if you toss a coin, you don't know whether it will come as head or tail unless it is Shole wala coin. So these are all called as experiments. Now, when you do an experiment, you get some results, and if you have an exhaustive set of results, that makes a sample space. For example, if you are flipping a coin, the results are either head or a tail, assuming that it doesn't stand. So it will be either head or a tail. And if you roll a dice, you will get either 1, 2, 3, 4, 5 or 6. So these are called your sample spaces. So these consist of all possible outcomes of the experiment, right? Now the sample space is the exhaustive list, but you might be interested only to know a particular event. So for example, if you are flipping a coin, you are interested to know if I get a head or not. So head becomes one particular event out of the total sample space of either head or tail. So event is a collection of desired outcomes. So what you expect? So in this example that I've taken, if I roll a dice, so I get either 1, 2, 3, 4, 5, 6 as my sample space. And suppose I want to understand what is my probability of getting an even output, that is only 2 or 4 or 6. So how many cases are there? This is one case, this is two, the second, this is the third out of the 6 cases. And mind it, all these 6 cases are equally likely, isn't it? So if it is a fair dice, the probability of getting a result is equal to 1 is nothing but 1 by 6. Similarly, probability of getting a result of 2 is equal to 1 by 6, because there are 6 options and each is equally likely. So each has an equal weightage. So here probability becomes required outcomes is 3. So these are 2, 4, 6 are the required outcomes out of the possible 6 outcomes, 1, 2, 3, 4, 5, 6, and hence the probability becomes 1 by 2. Now a deeper understanding. We call 2 events as mutually exclusive events. What does that mean? Suppose you have a pack of 52 cards and you take out one card. That card can be either a king or a queen or some other card. So having a card which has both king and queen is not possible. So getting a king and getting a queen are both an mutually exclusive event. Similarly, if I roll a dice and I want to get 1 and 2, I cannot get 1 and 2 simultaneously. So either I can get 1 or I can get 2 in one roll. So getting a 1 and getting a 2 are both mutually exclusive events. Then there is a concept of independent events. Independent events are basically different experiments. For example, you roll a dice, you get some result, and then again you roll a dice. So again you roll a dice, then it is a second experiment. So both are independent. The first outcome has no bearing on the second outcome. In the first outcome you may get say 1, and the second time when you roll a dice you will get a 6 probably. So you basically, in the 2 experiments, you can get a something like matrix of 6 by 6. Suppose you get in the first you get 1 and second you can get 1. Suppose you get first time 1 and then second time you get 2. Suppose first time you get 1, second time you get 3, and so on up to 1 and 6. So first time you have got 1, and then in the second event you can either get 1, 2, 3, 4, 5 and 6. Similarly, if I get 2 in the first event, and then I can get 1 in the second event, and so on, and up to 2 to the power 2 and 6, and continue up to 6 and 1 and 6 to 6. That means in the first rolling of dice you got 6, and then in second rolling of dice you got 1. So there are how many possible combinations? 36 possible combinations are there. What used to be only 6 sets, 1, 2, 3, once if you roll only one dice, you get 1, 2, 3, 4, 5, 6, only 6 cases. But if you roll a dice again, now you have a combination cases of 36. First 6 into next 6, 6 into 6, 36. So now, so now the probability of getting 1 in first chance, in first roll of dice, and probability of getting again 1 in the second chance is how much? This becomes 1 by 6 into 1 by 6. That is this, as you can see in this matrix, getting 1 and 1 is one such event out of 36 possible equally likely events. So naturally the probability is 1 by 36. So this was a basic on probability. Now let's come back to our problem. In the problem, it has been said in the first line that the probability of any random person getting infected by COVID-19 is 1 by 1000. Again, I reiterate, this is just an example, not a real thing. Just take it as a probability case. So if I say that a probability of getting infected is 1 by 1000, then probability is P infected with, so there are two events. Either someone is infected with COVID or someone is not infected with COVID. These are the only two possible outcomes. So probability of having COVID is, in fact, COVID infection is P equal to 1 by 1000, and probability of not having COVID infection is 999 upon 1000. Is it clear? Because these two will add up to 1. Probability always adds up to 1. Total, if in a whole sample space, all the probability adds up to 1. So this is 1 by 1000 and this is 999 by 1000. And as you can see, these two are mutually exclusive events, as we discussed earlier. What do you mean by mutually exclusive events? So either you can have a probability, either you will be COVID infected or you will not be COVID infected, right? So these are the only two possibilities, and these both are mutually exclusive. So this is what we get from the first line of the problem. Now let's move into the subsequent lines of the problem. Now it has been said that the kit gives 5% false result when the test is administered to infected people. What does it mean? It means that you have a sample of infected people, all with COVID cases, and you administer this kit to each of them. Then in out of 100 cases, 95 cases will report that yes, the person has infection. But there are also chance that 5 of the cases will report that they have no infection. In other words, reliability is a issue. 95 times out of 100 it is very reliable, but 5 times it may give wrong result. Wrong result in this case is, it's an infected case, they have infection, but you find that they are not infected, and that's why you do subsequent tests also. So this happens in everything, any manufacturing also, anything that you have, you cannot be 100% sure. So you try to be as accurate as possible, but there is always some level of discrepancy. So here, come back to the problem. So that means, so if we have a group of infected people, then correct reporting of COVID, the probability becomes how much? Probability is 95 upon 100, because it's giving 5% false result. So this 5% false result is basically the person has COVID, but the test, after doing the test, it shows that he or she doesn't have COVID. So that means there are 5% cases which are wrongly reported. So the probability of false result is 5 by 100. Mind it, this is for a sample of infected people, right? Only infected people. So infected people getting the test administered, 95% the test will say that yes, the person has COVID. 5% time it will say that they don't have COVID infection, although they have. So this is the thing. Now come to the next line. The next line says that if the kit is administered to healthy people, mind it, only healthy people, then it gives 99% accurate result. So what does that mean? That means that if I have a group of 100 people and the kit is administered to each of them, so chances are that the 99 people, they will report that they don't have COVID infection, but for one person it may give a false result. That means the person is healthy, but the kit will give a result that it has infection. So here also we can write that probability is, for a healthy people, correct result of no COVID 99 by 100, and false result of having COVID, probability is equal to 1 by 100. So now we have three sets of probability. One is probability of the population, wherein we know that 1 by 1000 of the population may have COVID infection. That was one first probability. Second was probability of infected people with the testing kit, says that 5% will have wrong result. And then third probability set, which is here, which shows that if you are administering the kit to the healthy people, there is a chance that 1% will go wrong. Now this whole scenario can be represented beautifully in a binary tree. So we have the complete population here, and as we see from the probability given, there is a chance that 0.001, that is 1 by 1000 of the population can be infected by virus, and therefore 999 by 1000 is not infected. Now as we saw the second set of probability, if the person is infected and then there's a group of infected people going for test, and as we see that test gives 95% accurate result. So probability becomes, because these two are independent events, one is the infection of the population and second is the testing. So these two are independent events, so the probability will get multiplied. So this probability shows the probability of persons who are infected and they have correctly tested positive. This set shows probability of infected person, but the test result shows negative. That means test shows no COVID. So this probability is how much? P is equal to 0.001 into 0.05. So this is the wrong cases. Now come to the not infected case. So if we have not infected case, again they go for the testing kit, 99% test correct, they don't have any COVID infection. So this shows that probability is P equal to 0.99, this is 0.999 into 0.99, right? So this is correctly shown. So this test shows that they don't have COVID, but there are probability that the person is not infected but results in a positive case. So this will show as probability of 0.999 into 0.01. Now if you take all this probability P1, P2, P3 and this P4, if you add them up all, it will all become 1. If you add P1 plus P2 plus P3 plus P4, it will become 1, showing that this is the complete sample space. So So far, I suppose that things are clear to you. We have a set of probability of the population. We have the set of probability for testing of a healthy person. We have a set of probability for testing of infected person. So this is how we can build the binary tree. Now let's again go back to the problem's last line. The problem says that a randomly tested person has turned out to be positive. What has happened? From the population, the testing has been done and the test result has come positive. Now the question is, if the test result has come positive, is the person having COVID infection or is the person not having COVID infection? Because we have seen that there are both cases, because we have infected person testing positive, fine, but we do have non-infected person also showing positive case, P3, right? If a result has come out to be COVID positive, means either of the two, these two can happen, right? So it can be either infected person testing positive or it can be non-infected person testing positive. Now by this example, we can see that our sample space has become only this two cases showing COVID infection. Out of this, actually the case where the person is actually infected is the first one, P1. The P1, that is P1 equal to 0.001 into 0.95. So your sample space is now this and this, P1 and P3, but actually the person who might have infection is the case of P1. So now the probability becomes what? Probability becomes the desired one, this desired one. The probability becomes this desired one out of the P1 plus P3. So the probability is just 0.0868. That is only 8.68%. So even if the test says that the person is COVID infected, actually in probabilistic term, there is only a 8.68% chance that he or she has infection. So this is how we can deal with a probability case. Thank you so much for watching our video. Share your thoughts on support@aptz.in. Thank you so much.